Good evening. Welcome to Soothing Sound Loop. Tonight, we will embark on a detailed exploration of engine repair. It is imperative to understand that successful engine repair is not an exercise in guesswork, but rather a methodical application of diagnostic principles and adherence to manufacturer specifications. This session will prioritize precision and process over entertainment. Before any substantive work can commence, a thorough understanding of the engine's current state is paramount. This involves a systematic approach to identifying the malfunction. We will begin by reviewing the foundational steps for initial assessment. Our discussion will not be rushed. Each step is a prerequisite for the subsequent one. Patience and attention to detail are critical. Deviation from established procedures can lead to further complications, negating any progress made. The initial phase of engine repair invariably involves a series of preliminary diagnostic steps. These steps, while seemingly mundane, are crucial for narrowing down the potential causes of engine malfunction. First, we must consider the vehicle's history. Has there been any recent maintenance? Were there any unusual noises preceding the malfunction? These are data points, not anecdotes, that contribute to a comprehensive diagnostic picture. One must gather all available data. Next, a visual inspection of the engine bay. Observe for obvious signs of fluid leaks. Identify any disconnected hoses or wires. Note any abnormal discoloration on engine components. This is a purely observational exercise. No conclusions should be drawn at this stage, merely data collection. Furthermore, verify fluid levels. Engine oil, coolant, and transmission fluid must be at their specified levels. A low fluid level can often be a primary indicator of a problem. Document these levels. It is also advisable to check the battery voltage. A discharged battery can mimic engine starting problems that are not directly engine related. Utilize a multimeter for this purpose. Ensure a stable reading. Prior to engaging with any engine component, it is absolutely essential to ensure the appropriate tools are at hand and that all safety protocols are strictly observed. Neglecting these aspects can lead to inefficiency, damage, or, in severe cases, personal injury. Common tools required for basic engine work include a set of metric and standard sockets, ratchets of various drive sizes, open-end and box-end wrenches, screwdrivers, pliers, and a torque wrench. Each tool serves a specific function and must be utilized correctly. A torque wrench, for instance, is not a standard tightening tool. It is a precision instrument designed to apply a specific amount of rotational force to a fastener. Its proper use prevents over-tightening, which can strip threads, or under-tightening, which can lead to component failure. Calibration of a torque wrench should be verified periodically. Regarding safety, the use of personal protective equipment, or PPE, is non-negotiable. Safety glasses protect the eyes from debris and fluids. Gloves protect the hands from chemicals and abrasions. Adequate ventilation is also paramount, especially when dealing with fuel or exhaust fumes. Engine components can be hot. Exercise caution. Disconnect the battery before commencing any electrical work. Always ensure the vehicle is stable and adequately supported if elevated. Jack stands, not just a jack, must be used. Review the vehicle's service manual for specific lifting points. Once preliminary observations are complete and safety measures are in place, the next phase involves more specific diagnostic tests. These tests aim to systematically isolate the faulty system, compression, spark, or fuel. We will first consider a compression test. This test measures the sealing ability of the engine's cylinders. A cylinder with low compression indicates a problem with the valves, piston rings, or cylinder head gasket. To perform a compression test, one must disable the ignition system and fuel system to prevent the engine from starting. Remove all spark plugs. Insert the compression gauge into each spark plug hole, one at a time. Crank the engine for a specified number of revolutions. Record the reading for each cylinder. Consistent readings are desirable. Significant variations are indicative of an internal engine issue. Next, the ignition system. A lack of spark at the spark plug can prevent combustion. To test for spark, remove a spark plug, connect it to its ignition wire, and ground the metal body of the plug against a suitable engine component while someone briefly cranks the engine. Observe for a strong blue spark. If no spark is observed, further investigation into the ignition coil, ignition module, or crankshaft position sensor is required. This test should be performed with extreme caution due to the high voltage involved. Finally, the fuel system. An engine requires the correct air-fuel mixture to operate. Issues with the fuel pump, fuel filter, or fuel injectors can lead to a no-start or poor running condition. A fuel pressure test involves connecting a fuel pressure gauge to the fuel rail. Compare the measured pressure to the manufacturer's specifications. If pressure is insufficient, consider the fuel pump or a clogged fuel filter. For injector issues, specialized diagnostic equipment is often necessary to test their spray pattern and flow rate. This requires precise measurement and often proprietary tools. Having systematically narrowed down the potential problem area, we can now discuss the procedures for addressing some common engine malfunctions. This section will maintain our commitment to a dispassionate, step-by-step methodology. Scenario A. Low compression diagnosis. If the compression test reveals low compression in one or more cylinders, the next step involves a cylinder leak down test. This test introduces compressed air into the cylinder and measures the percentage of leakage. The location of the air leak, e.g., intake manifold, exhaust manifold, crankcase, indicates the specific component that has failed, such as a burnt valve, worn piston rings, or a damaged head gasket. Repair would then involve engine disassembly to access the affected components, followed by their replacement according to service manual specifications, paying particular attention to torque values and sealants. Scenario B. No spark condition. If the ignition system is identified as the culprit, a systematic approach to component testing is necessary. Begin by testing the ignition coil for resistance and voltage output. Consult the service manual for specific resistance values. If the coil tests within specifications, proceed to test the crankshaft position sensor or camshaft position sensor if equipped. These sensors provide critical timing signals to the engine control unit, ECU. Diagnostic trouble codes, DTCS, retrieved with an OBD2 scanner, can often provide guidance here. Replacement of faulty components should follow the manufacturer's removal and installation procedures precisely. Wiring harness integrity should also be verified. Scenario C. Fuel delivery issues. In the event of insufficient fuel pressure or improper fuel delivery, a multifaceted approach is required. First, the fuel filter should be replaced as a matter of course if its service history is unknown. A clogged fuel filter is a common cause of fuel starvation. If the filter replacement does not resolve the issue, the fuel pump itself must be tested. This may involve checking voltage at the pump or directly testing its output pressure and volume. Fuel injector cleaning or replacement might be necessary if individual injectors are found to be faulty. Each step in the fuel system diagnosis requires careful handling of flammable liquids and strict adherence to fire safety protocols. The process of reassembly is as critical, if not more critical, than the disassembly phase. Errors during reassembly can lead to immediate failure or long-term damage. Precision is paramount. All fasteners removed during disassembly must be reinstalled with the correct torque specifications. This cannot be overstated. Over-tightening can strip threads or deform components. Under-tightening can lead to component separation and leaks. Utilize a calibrated torque wrench for all critical fasteners, such as cylinder head bolts, connecting rod bolts, and main bearing cap bolts. Refer to the specific service manual for each unique fastener's torque specification. Do not rely on generalized torque charts. Gaskets and seals must be replaced with new OEM quality parts. Used gaskets and seals compromise the integrity of the engine's fluid retention and sealing surfaces. Apply appropriate sealants as specified by the manufacturer, ensuring complete coverage without excess that could foul internal passages. Surfaces where gaskets are installed must be meticulously clean and free of old gasket material or debris. During reassembly, pay close attention to the routing of wiring harnesses and hoses. Ensure they are not pinched, kinked, or in contact with hot or moving engine parts. Proper routing prevents future chafing and electrical shorts or fluid leaks. This is often an overlooked but vital step. After all components are reassembled, a series of post-repair verification steps are necessary before returning the engine to service. Fill all fluids to their appropriate levels. Bleed the cooling system if any cooling system components were disturbed. Perform a final visual inspection for any tools left behind or any loose connections. In conclusion, the repair of an internal combustion engine is a precise, multi-step process that demands patience, adherence to procedure, and an unwavering commitment to detail. There are no shortcuts. Each step builds upon the previous one, culminating in a functional engine. Ongoing maintenance remains crucial even after a repair. Regular oil changes, filter replacements, and scheduled inspections can prevent many of the issues discussed today. A proactive approach to vehicle maintenance is always more cost-effective and less disruptive than reactive repairs. This concludes our comprehensive, albeit unexciting, overview of engine repair procedures. The information presented is intended to serve as a foundational guide for those undertaking such tasks. Further detailed information should always be sought in the vehicle's specific service manual. Thank you for your sustained attention. This will be for sleep aid. Goal is to have boring subject put you to sleep. Of course. I can adapt the script to be even more effective as a sleep aid. The key is to make it not just boring, but also incredibly monotonous and repetitive, with a focus on procedural details that require minimal mental engagement. Here is a 30 to 40 minute script for a sleep aid, focusing on the incredibly dull subject of engine repair. Welcome, please settle in. Today, we will not be moving quickly. We are simply going to observe the methodical, step-by-step process of reassembling an engine. There are no sudden noises here, only a quiet, deliberate sequence of actions. We will begin with the bottom end of the engine, the foundation. It is a quiet process, a process of precision and patience. You do not need to do anything but listen. Just let the words wash over you. There is no test at the end. Our first task is to place the main bearings into the engine block. These are simple half circles of a soft metal alloy. There are a specific number of them, and each one has a specific position. We will place them one by one. The first one goes into the front main bearing journal. It is a smooth, quiet placement. We will apply a very thin layer of assembly lube to the bearing surface. This is a simple, viscous fluid. It is slick. We apply it with a finger, moving slowly along the surface. This is a simple, repetitive motion, back and forth. back and forth. Now, the second main bearing, placed, the third, placed, and so on, until all the main bearings are resting in their assigned places. It is a simple counting exercise. No excitement here, just numbers. 1, 2, 3, 4, 5, depending on the engine. With all the bearings in place, we can now gently lower the crankshaft into the block. This is a heavy steel component. We do this very slowly. We guide it down with no sudden movements. It simply settles into the main bearings. A gentle, quiet settling. Now, we apply more of the assembly lube to the top side of the crankshaft's bearing journals. Again, a simple, repetitive motion. A quiet, slick application of a viscous fluid. Now, we will place the main bearing caps on top of the crankshaft. Each cap has a number. They must be placed in a specific order and in a specific orientation. We will place the first cap. It has a number 1 on it. It goes in the number 1 position. We just lay it down gently. Each cap has 2 bolts. We will thread the first bolt in by hand, just turning it slowly until it is finger tight. Then the second one, just a simple, quiet threading. We will repeat this for all the main bearing caps. Placing the cap, threading the first bolt, threading the second bolt. It's a very simple, repetitive cycle. Placement, threading, threading. No variation. No surprises. Now, we will introduce the torque wrench. This is an instrument of precision, not speed. We will tighten each bolt in a specific sequence and to a specific torque value. We do not hear a sudden click. We listen for a soft, definitive click. The first bolt, a quiet click. The second bolt, a quiet click. We will repeat this. 1 click, another click, another click. The service manual provides the exact torque value. For example, 60 foot-pounds. This is just a number. It is a quiet, specific number. We will tighten each bolt in sequence, and then tighten them again in a second pass, all to the same, quiet, specific number. The sequence is often from the middle, moving outward. We just follow the numbers. Nothing more. Now, we turn our attention to the pistons and connecting rods. Each piston and rod assembly must be inserted into its corresponding cylinder. Each one is numbered. We start with number 1. We apply a thin film of oil to the cylinder wall. A very thin, quiet film. We then compress the piston rings using a special tool, a ring compressor. This is a very simple, circular tool. We just tighten it gently around the piston. It is a slow, quiet tightening. With the rings compressed, we can gently guide the piston into the cylinder bore. We tap it gently, just enough to get it to slide in. A quiet, soft tapping sound. It just slides down, smoothly, into the cylinder. We will do this for each piston. Tapping, sliding, down, into the cylinder. Once all the pistons are in place, we can move on to the cylinder head. This is a heavy component. We lower it onto the engine block very slowly and carefully. It is aligned with dowel pins. It just slides down and settles into place. A simple, quiet settling. Now, the head bolts. There are many of them. We will thread them in by hand first, one by one. Just a quiet turning of each bolt. We do not tighten them yet. We just make sure they are all in place. A slow, steady rhythm of threading. With the cylinder head in place, we can now install the camshaft. It is a long, cylindrical component. We slide it into its bearings with great care. It is a slow, gradual slide. Quiet, consistent. We apply a little more assembly lube to the cam lobes. A simple, repetitive application. Now, the timing chain or belt. This is a crucial step, but we will simply observe the placement of the markings. There is a mark on the crankshaft gear. There is a mark on the camshaft gear. We just align them. We look at the mark here, and the mark there, and we make them line up. It is a very simple visual alignment, a quiet, specific alignment. Finally, we can go back to the head bolts. We will again use the torque wrench. We will tighten them in a very specific sequence, following the manufacturer's pattern. It is a spiral pattern or a crisscross pattern. We will just follow the numbers. The first bolt, click. The second bolt, click. The third bolt, click. We will continue this sequence back and forth from the center, moving outward, just listening for the quiet clicks. One by one, over and over again. Once all the head bolts are torqued, we can quietly install the valve cover, just a simple cover. We tighten its bolts in a specific sequence, just as we did before. We apply a little sealant to the gasket, a quiet, repetitive motion. The engine is now reassembled. Every bolt has been torqued. Every gasket is in place. Every component is where it should be. The process is complete. There is no sound, just the quiet stillness of the engine. There is nothing more to do, just rest. Let the quiet clicks and the simple movements drift away. The work is done. It is time for you to rest now as well. The engine is quiet, and you can be quiet too. Good night.